Hi everyone. In this video, we will see differentiation tricks that every engineering student should know. Have you ever found yourself spending too much time solving differentiation problems? Do lengthy calculations and complicated formulae make engineering mathematics seem difficult? If so, you're not alone. Many engineering students lose valuable marks in examinations not because they don't know the concepts, but because they spend too much time on calculations or make avoidable mistakes. The good news is that differentiation doesn't have to be difficult. By learning a few simple tricks and shortcuts, you can solve problems more quickly, improve your accuracy, and gain confidence in mathematics. In this video, we will explore some powerful differentiation techniques that every engineering student should know. So in this video will help you explore about to reduce calculation time during examinations, recognize the easiest approach to solve a problem, avoid common mistakes that lead to wrong answers, understand when to use the power rule, product rule, quotient rule, and chain rule, develop faster problem solving skills for competitive exams and university assessments. Whether you are studying first year engineering or preparing for semester examinations or simply looking to strengthen your calculus fundamentals, these tricks will make differentiation much easier and more enjoyable. We will cover practical shortcuts such as using the power rule to avoid unnecessary multiplication, simplifying expressions before differentiating, easy memory tricks for the product rule and quotient rule, a simple approach to mastering the chain rule. So by the end of this video, you will discover that differentiation is not about memorizing numerous formulae. It is about recognizing patterns and applying the right technique at the right time. So if you are ready to save time, improve your speed and solve differentiation problems like a pro, let's get started. So the very first thing, remember the fundamental derivatives. The power rule. D by dx of x power n is equal to n x power n minus 1. So example, x power 5 can be differentiated as 5x power 4 and x power 8 is 8x power 7. So exponential functions. D by dx of e power x is always e power x and d by dx of a power x is a power x ln a. Logarithmic function d by dx of ln x equal to 1 by x. Now trigonometric function, sin x when you differentiate you will get cos x. Cos x when you differentiate you get minus sin x. Tan x when you differentiate you get secant squared x. And secant x when you differentiate you get secant x tan x. So the trick is memorize these formulae thoroughly. They are the foundation of all differentiation problems. So the very first thing is remember the fundamental derivatives. That is some basic formulae that you have to remember. Now, second one, use the power rule instead of multiplication. One of the biggest mistakes that every student will make is expanding or multiplying expressions unnecessarily before differentiating. The power rule provides a much faster and easier method. So d by dx of x power 7. So directly you can apply 7x power 6. Never expand unnecessarily. Use the power rule directly. That is a trick that you have to remember. Simplify before differentiating. So most effective strategies in engineering mathematics is always simplify an expression before applying differentiation rules. By simplifying first, you can avoid lengthy calculations, reduce errors, and save valuable time during the examinations. Why should we simplify first? Many functions can be written in a simpler form using algebraic operations such as cancellation, factorization, division, converting radicals to powers. Once simplified, the differentiation becomes much easier and often eliminates the need for complicated rules like product rule or quotient rule and etc. So when I take an example, y equal to x cube plus x squared divided by x. So instead of you applying quotient rule when you see the division here, instead of doing that, first let me cancel this x cube divided by x, I get x squared, and x squared divided by x I get x. So now easily I can do the differentiation dy by dx equal to 2x plus 1. So the trick is simplification saves time and reduces mistakes. Product rule. So the shortcut for product rule. When a function is the product of two functions, we use the product rule to find its derivative. Example, d by dx of uv is u into dv by dx plus v into du by dx. For example, when I take y equal to x squared sin x, here x squared will play, u will take x squared and v will take sin x. So dy by dx I get x squared cos x plus 2x sin x. So the memory trick is first variable into derivative of second plus second variable into derivative of first. So this is actually the product rule is. Quotient rule. When one function is divided by another function, we use the quotient rule for such as, for example, y equal to u by v. So d by dx of u by v equal to v into du by dx minus u into dv by dx divided by v squared. So the easy memory technique is bottom into derivative of top minus top into derivative of bottom, all divided by bottom squared. For example, when I take y equal to x squared plus 1 divided by x, first, as we discussed earlier, let us simplify first before applying any of the differentiation techniques. So I get y equal to x plus 1 by x. So dy by dx is 1 minus 1 by x squared. So whenever possible, we simplify before applying quotient rule. Now chain rule, how it is made easy. The chain rule is used when one function is inside another function. In other words, it is used for composite functions. dy by dx equal to dy by du into du by dx. For example, if I take y equal to 3x plus 1 the whole power 5, outer function is u power 5. Now derivative is 5u power 4 and the inner function is u equal to 3x plus 1. When I differentiate this 3x plus 1, again I get 3. So the final answer is dy by dx equal to 15 into 3x plus 1 the whole power 4. So the differentiate the outside first, then multiply by the derivative. Implicit differentiation trick. Usually we differentiate equations where y is expressed explicitly in terms of x, such as y equal to x squared plus 3x plus 1 times y. However, sometimes x and y are mixed together in the same equation, making it difficult or impossible to express y directly as a function of x. Such equations are called implicit functions, and we use implicit differentiation to find dy by dx. Given x squared plus y squared equal to 25, so when I differentiate this, I get 2x plus 2y dy by dx equal to 0. So dy by dx equal to minus x by y. Whenever differentiating y, we have to, whenever we are differentiating y, multiply by the corresponding derivative. Logarithmic differentiation is a powerful technique used to differentiate functions that are difficult to handle using ordinary differentiation rules. It is especially useful when both the base and exponent contain variables. The function is a product or quotient of several terms with powers. The expression contains roots and fractional powers. So this is very much useful for complicated functions when y equal to x power x. So taking logarithm on both sides, I get ln y equal to x ln x. So when I differentiate ln y, I get 1 by y dy by dx, which is equal to ln x plus 1. Hence dy by dx equal to x power x into ln x plus 1. So common mistakes that you can avoid, d by dx of sin x equal to sin x. So this usually the students will do. It is not sin x. And d by dx of sin x is nothing but cos x. And d by dx of e power x is x e power x minus 1. No, whenever exponential powers are there, it is e power x only. Then forgetting chain rule. If I give us d by dx of sine 3x, they will simply write as differentiation of sine is cos. So cos 3x. You should not forget to apply chain rule. So it is 3 cos 3x. So the conclusion is differentiation becomes easy when you know the right tricks. Master these shortcuts, practice regularly, and you will be able to solve engineering mathematics problems with confidence. Thank you.